Have you ever wondered why our planet features such an incredible mosaic of environments, from the scorching aridity of deserts to the lush, constant dampness of tropical rainforests? It is truly astounding to think about the vast range of climates that exist, each supporting its own unique forms of life and shaping human experience. How do we make sense of all this diversity? Well, at the heart of understanding Earth's diverse climates lies the brilliant Köppen climate classification system. This system reveals that global climate patterns are not random, but instead from predictable bands and regions across the planet. These patterns are largely dictated by factors like latitude, continental position, ocean currents, and elevation, creating distinct and recognizable climate zones around the world. The fundamental driver of these global patterns is the distribution of solar energy. Regions near the equator receive direct, intense sunlight year-round, leading to our tropical climates, or climates in the Köppen system, with their consistent warmth and often abundant rainfall. As we move away from the equator towards the poles, the angle of the sun's rays becomes more oblique, spreading energy over a larger area and leading to less intense heating. This creates a gradual transition through temperate zones, or C and D climates, characterized by distinct seasons, before culminating in the cold polar or E climates. Beyond this latitudinal control, the presence of large landmasses versus oceans plays a crucial role. Continental interiors, far from the moderating influence of water, often experience greater temperature extremes and can be much drier, leading to extensive dry B climates. Conversely, coastal areas benefit from oceanic influences, which can moderate temperatures and increase precipitation. Major ocean currents also redistribute heat and moisture globally, such as the warm Gulf Stream bringing milder conditions to Western Europe, or cold currents contributing to coastal deserts. Finally, elevation significantly impacts local climates. Mountain ranges can block moisture-laden winds, creating arid rain shadows on one side while fostering lush conditions on the other, and temperatures generally decrease with increasing altitude. So, when you look at a map of Köppen climate zones, you can clearly see these patterns. You will notice broad, general bands corresponding to the major latitudinal groups. For example, the tropical climates generally hug the equator, followed by dry B climates in subtropical belts, and then temperate C and D climates towards the mid-latitudes, before the polar E climates dominate near the poles. Within these broad bands, you can then identify the more specific subdivisions. These finer details are shaped by those local factors we just discussed, such as how close a region is to an ocean or if it is in the rain shadow of a mountain range. Recognizing these connections helps you interpret the climate type and understand the typical vegetation and even human activities you might find there. To get an even deeper understanding of these patterns, geographers often use what are called climatographs. These are simple graphs that display the average monthly temperature and precipitation for a specific location, offering a detailed snapshot of its climate. Analyzing climatographs from different Köppen zones truly brings these global patterns to life. Think about the Mediterranean climate, or CS in the Köppen classification. It is characterized by dry, hot summers and mild, wet winters, and you find it in very distinct, non-contiguous regions across the globe. The Mediterranean basin, parts of California, central Chile, the Cape region of South Africa, and parts of southwest Australia. This unique pattern highlights how specific combinations of latitude, ocean currents, and atmospheric circulation create very particular conditions in widely separated places. Ultimately, grasping the global patterns of Köppen climates is more than just memorizing categories. It is about understanding the interconnected systems that govern our planet's environments. This knowledge empowers us to predict where certain ecosystems will thrive, comprehend historical and present human settlement patterns, and even anticipate how environmental changes might redistribute these vital climate zones in the future. It provides a fundamental framework for seeing the world with greater clarity and appreciation.